Welcome to Math 135, looking at polynomial equations and inequalities. So now with equations, you need to be very careful. First, you're going to set them equal to 0 and factor if it's possible to factor. Then you need to be careful to not divide by your variable. Why can't we divide by our variable? Well, because sometimes your variable might be equal to 0. And if your variable is equal to 0 and you're dividing by it, that means you're dividing by a 0, which we know we can't do. So be careful. Again, the plan, set equal to 0 and use the zero factor property, if it's possible. So for this first one, we have x cubed equals x squared. So I'm going to go ahead and set it to 0, and I'll minus the x squared from both sides. When I do that, I get x cubed minus x squared equals 0. Now we'll go ahead and factor. Okay, so I have set them equal to 0 and I've factored them. Now I'm going to go ahead and use the zero factor property and set each item equal to 0. I just use this little line down here to show that I'm working by different factors. Very important, please set each factor to 0 and then solve. So now I know x equals 0 and x equals 1. And then we're done. Not too bad. Now this next one. Let's see, it's already set to 0, we see that, so what do we need to do now? Well, how many terms are there? I'm thinking of factoring, right? There are 4 terms, and I'm trying to factor this, which again is my plan. Well, I'm going to try factoring by grouping, which is usually what we do when we have 4 terms. So again, we're factoring by grouping, so I'm going to go ahead and group the first terms together, and then the second terms together. And this is the way we first started. Sometimes it doesn't always work in that order, but again, it's a great way to start. However, when I put those parentheses in for the end terms, I need to be careful because of that negative. If I put those parentheses in and then I was to multiply back in that negative, a negative times a negative would give me a positive. That's a problem. So to change that, when I put the parentheses in, this one's going to become a negative sign. Let me show you what that is. So the first 2, again, I don't need to worry about what I do when I group them, but when I keep that negative sign, in order to make sure my problem's the same, I'm going to go ahead and have to change the negative to a positive 57. Equal to 0. And when I do that, if I needed to distribute in that negative in between my parentheses, again, I would get back my original equation. So now when I've grouped them, I'm going to try factor each grouping specifically. In the first one, do they share anything in common? Well, they both have an x squared I can factor out. So that'll be x plus 3 minus. Now, the next group, do they have anything we can factor out? Well, 19 goes into 57 3 times, so I can factor out a 19. And I'm left with x plus 3 equal to 0. So now, as we do with grouping, looking at these, oops, wrong color, these 2 different terms, do they share anything in common? Well, they both share an x plus 3, so I'll go ahead and factor out the x plus 3. And what's left over? Just the x squared minus the 19. All right, look, we have it factored equal to 0. That was my plan. So let's use the zero factor property and set both of the factors equal to 0 and then solve. So x is going to equal negative 3. And then x squared equals positive 19. Got to use the square root property here. Remember the plus or minus. And we get that x equals plus or minus the square root of 19. And we're done. Again, the plus or minus is very important because right now we have 3 different possible solutions. Negative 3, the positive root 19, and the negative root 19. If we didn't remember the plus or minus, we would only have 2 of our 3 solutions. So be careful on that. Now, moving along. So, we have an equation here. Let's see. Is it set equal to 0? No, it's not. We have a 3 on that side. So I want to set it equal to 0, so I'll minus 3 from both sides. Then I have 2x to the 4th minus 5x squared minus 3 equals 0. I'm trying to factor this. They don't share a common factor. What I do notice is I have an x to the 4th and an x squared. Those are kind of big powers. You know what I'm thinking of doing is substitution. Because I'm not really good at factoring. Well, I mean, you could see it, but for me, I don't really like factoring with big powers like that. So I'm going to go ahead and do substitution. So I say let, L-E-T, u equal the lowest power, which would be x squared. So So let u equal x squared. Well, when I sub that in, let me rewrite this first one, that's going to be 2 times x squared to the second power, right? That would become x to the 4th. Minus 5 times x squared minus 3 equals 0. So now I'm going to go ahead and substitute in that x squared wherever I see x squared, which is here and here. I'll replace them with u. Hence the name substitution. That's what I'm doing for solving. So that'll be 2u squared minus 5u minus 3 equals 0. Now this is something that looks like a regular quadratic, which we're used to factoring. So I'll go ahead and factor this like a regular quadratic. My two different binomials. Let's see, we're trying to use some factors that when I subtract, I get a negative 5. So we can factor this into 2u, u, and then let's see. Outer term u minus 3 and u plus 1. Again, if you need any help remembering how to factor the quadratics, please let me know and I'll send you a worksheet. So now, factored set to 0, what do we do? Well, we're going to do 2u plus 1 equals 0, and then u minus 3 equals 0, and solve. So u is going to equal negative 1/2, and u is going to equal 3. Are we done? No, we're not, because remember, we're trying to solve for x, not u. So I'm going to have to re-sub in my x squared. Because remember, u equals x squared. So now I have x squared equals negative 1/2, and x squared equals 3. We got to go ahead and use that square root property. So square rooting both sides. On the right side, I get x equals plus or minus the square root of 3. However, on my left side, what do you notice? I have a negative under a radical. So if we were solving over real numbers, that would be no solution, because we have a negative under a square root. However, if we're solving over complex number solutions, we could include I, the imaginary number. So let's go ahead and continue into the complex numbers. That'll be the square root of negative 1/2, which again is going to be x equals plus or minus the square root of 1/2 I. So again, pulling out that negative in the radical, replacing it with I. And then I'm going to go ahead and simplify the square root of 1/2. So let's see, that would be rationalizing the denominator. I need to multiply the top and the bottom by a square root of 2. Again, we're rationalizing the denominator. We don't want to have a radical in the denominator, so we would have square root of 2 over 2i. And there we go. Again, that's if you're solving over complex numbers. If not, you would say that had no solution. All right, let's take a look at the next one. X to the 6th power minus 64 equals 0. Now, because this is x to the 6th power, I'm not going to try the square root property. That's better when you have an actual x to the squared power. So I'm going to see if I can factor this. Now, whenever I see a minus sign and a perfect square number, 64 is 8 times 8, I'm thinking this might be the difference of squares. As you recall, a squared minus b squared equals a plus b times a minus b. So I'm going to try to write this in terms of something squared minus something else squared. Can we do that? So that is going to be x to the 3rd power squared minus 8 squared. Look, we did it. So let's go ahead and square that, or factor that out. That'll be x cubed minus 8 times x cubed plus 8. Are we done factoring? Well, those of you that remember, whenever you see a cube, you have to ask yourself, is this the sum or difference of cubes? Well, I have a minus sign here and a plus sign here. So the next question is 8 a perfect cube number? It is. 8 is 2 times 2 times 2. So these are both perfect square or perfect cubes. The first one is the difference of cubes. The second one is a sum of cubes. So factoring those using our factoring properties, we have x minus 2. Actually, let me color code this so you know which one I'm factoring. So I'll do the first one as blue. X minus 2. Let me erase that so you can see it. Again, the first one I'm going to factor into the blue factors. So x minus 2 times x squared plus 2x plus 4. And then the other one I'll do in red. Fraction, that'll be x plus 2 times x squared minus 2x plus 4. Very similar, just a difference in signs. Okay, so it's all factored. We factored into 4 different terms. The question is, are these factorable? The answer is no. They're prime if they come from a difference or sum of cubes, and you checked that there was no common factor before. So we know they're prime. So let's go ahead and write all these equal to 0 to solve. I'm going to rewrite this so we have the binomials first. So let's see, that's going to be x minus 2 equals 0, x plus 2 equals 0, then x squared plus 2x plus 4 equals 0, and lastly, x squared minus 2x plus 4 equals 0. Again, setting them all equal to 0. The first two are simple. We just go ahead, set them to 0, solve. Now the next two are not quite as simple because remember, they're not factorable. So if we can't factor, there's 2 ways to solve. We could complete the square and solve, or we could do quadratic formula. I'm going to go ahead and do quadratic formula in one and completing the square in the other. So for the first one, let's do completing the square. To do that, we'll minus the 4 from both sides. And we want to find a perfect number to add into our problem that'll make a perfect square binomial. To do that, we take our middle term and half it, and then square it. So that is going to be 1 squared, which is 1. So my perfect number to add to my problem is a positive 1. But when I add it to one side, again, remember, I need to add it to the other side to balance my equation. I can't make my equation unbalanced. So then I have x squared plus 2x plus 1 equals negative 3. So now I know the trinomial that I've created can be factored. Again, that was the goal. That was why I added that plus 1. So I could make this a perfect square binomial. So that'll be x plus 1 times x plus 1 when I factor it, which again can be rewritten as x plus 1 squared, since there's 2 of them. And now let's go ahead, square root both sides to solve, since we have a square. Oh, notice we have a negative sign inside our radical. So option 1, no solution, since it's an imaginary number, or option 2, we solve over complex. So for now, again, I'll go ahead and solve into the complex realm. Let's continue on. Again, if not, we would have said it's an imaginary number or no real solution. And then lastly, getting x by itself will minus 1 from both sides. And x equals negative 1 plus or minus the square root of 3 times I in complex number form. Okay, so again, as I mentioned, I was going to solve both of those in 2 different ways. The first way I did completing the square. Second way, I'm going to do quadratic formula, which again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now who is a, who is b, and who is c? That number there, the magical 1, is a. This number here is b. And this number here is c. Again, b is by the x to the 1 power. C is the one that does not have a variable, and a is the one with x squared. So let's go ahead and plug those values in. So my b value again was red, so negative 2, negative 2. My c value is blue, and my a value is green. So let's go ahead and simplify. All right, oh, again, we have that negative under the radical. So at this point, you could stop and say, not a real number. However, we'll continue to the complex realm and make that into the imaginary I. Oh, sorry, that shouldn't have been 9. Let's see, that's going to be 4 minus 16. That's going to be 12. Okay, so that'll be the 12. And when we simplify this, we'll get x equals 2 plus or minus. Simplifying that 12, that'll be 2 root 3i all over 2. Now we can factor out a 2 from every one. So that'll be x equals 2 times 1 plus or minus root 3i divided by 2, and then the 2's would cancel. And we're left with, let's see if I can squish this in, x equals 1 plus or minus root 3i. And we're done. Alrighty, so we have a lot of answers. How many do I have? I have 1, 2, 3, and 4, because remember the plus or minus, and then 5 and 6 answers if we solve in the complex realm, or the complex numbers. So now example 2, graph the polynomial and then solve. And we'll look for A, B, and C. So first, let's go ahead and graph our polynomial. Again, some of the key values we're going to look for. First one, what do we know? And sorry for the sound quality right now on my video. My microphone isn't quite working. Again, apologies on the sound quality. Well, what do we know? Let's see. Well, first, again, we can find the zeros, right? Pulling that off from there, we know we'll have x is 0. That's x going to be 4. And then x would be negative 3. Those are our zeros. What else can we look at? Well, we can take a look again at our leading coefficient. We have a positive coefficient, again the positive 1, and then we have an even power. So because of that, we know the arms of our graph are going to look something like this, pointing upwards. What is one other thing we can do? We can look at the multiplicity. Well, these first two all have multiplicity 1, so we know it's going to pass straight through. However, at 4, it's squared. So we know at 4 equals x, we're going to have a bounce. It's going to hit our value and then head back up. Okay, so with this, let's go ahead and graph. Again, just a small, quick graph. Doesn't need to have a lot of detail to it. It's just a sketch. We're looking at 1, 2, 3, so negative 3. 1, 2, 3, 4, positive 4. And 0. Those are my zeros. Now, what do we know about my graph? They need to be up on both sides. So we know it's going to pass through 3 because it has a multiplicity of, 1. So it'll pass through 3. And then what happens? Well, it has to go up and pass through 0. But it's not going to bounce again because that just has multiplicity of 1. So it just passes through 0. And then it needs to hit 4 because, again, remember, that's a 0. But what happens at 4? Well, it's going to bounce. We have a multiplicity of 2. So it'll pass through there, and it'll go up. We don't know how high. Again, it's just a sketch. We don't know how high. And then it'll go ahead, bounce up. Let me go ahead and erase that end. It'll bounce up and continue off into infinity. So again, just a sketch. You don't know how high or how low this is going here. We just know that it passes through 3 and 0, and it bounces on 4. So there we have our sketch. I'll go ahead and erase that. Again, we don't need to know how high or how low at this time. So next, my question is, or the question is A. When is p of x equal to 0? Well, we know that those are going to be at our zeros, right here. So p of x equals 0 at x equals negative 3, x equals 0, and x equals 4. What is the next question? The next question is, when is my polynomial less than 0? So my polynomial is less than 0 when it dips below the x-axis, and that is right along here. That is when it is less than 0. So again, we're talking about the y values, but we're going to answer in the x values. So what x values are those? Those x values are from between negative 3 to 0, not including. All right. And then lastly, we're going to take a look at when p of x is greater than 0. So that's all the values above the x-axis. And that is these values here, these ones, and these ones. We don't include where it's equal to 0. So again, there's going to be a small gap there. But we have 3 different segments where it's greater than 0. So for C, where p of x is greater than 0, we are looking at the intervals. Negative infinity all the way up to 3, but we stop. Then we union again at 0. We start again until we hit 4. We have a small pause because again we can't let it be equal to 0, just greater than. Then we union and we continue on from 4 to positive infinity. So that is it for this video. If you have any questions, please send me an email.